A relation is a mapping or pairing of input values with output values. A relation is nothing more than saying this set of numbers goes to this set of numbers. A domain is the set of input values. The domain is also called the independent variable, or X. The range is the set of output values. It is also called the dependent value, the dependent variable, or Y. And that makes sense. The domain is the independent variable. The range is the dependent variable. Depending on what number this is, it's going to give us our range, our output value. A function is a relation, so it's a mapping or a pairing of input values to output values, but it's a special mapping, it's a special relation with exactly one output for each input. Problem number 1. State the domain and range of the relation. If we look, we have a mapping of input values to the output values. This is a relation. So step 1 is to state the domain and the range. The domain will be a set of numbers, so we're going to use set notation, a bracket, and we're going to list all the numbers in our domain starting with our smallest value. Well, here's all our domain. Our smallest value is -8, followed by 3, 6, and 7. And then I'm going to close the bracket. Our range is also a set of numbers, so I'm going to use set notation. I'm going to start with my smallest number, -2, followed by 4, followed by 5. If you notice, I should have 5 twice in my range, but I only need to list it once in the set. Now I need to decide if the relation is a function. To decide if this is a function or not, I need to look at how the inputs go to the outputs. 3 is mapped to 5, 6 is mapped to 5, 7 is mapped to -2, -8 is mapped to 4. For this relation to be a function, every input can only have one output. If we look, every input does only have one output. Be careful, just because this 5 has 2 inputs doesn't make this not a function. The thing we're looking for is all of these inputs have exactly one output. So yes, this is a function. Let's look at the graph of this relation. 3 maps to 5. So I'm going to go to the right 3 and output 5. 3, 5. 3 gets mapped to 5. 6 gets mapped to 5 also. Seven gets mapped to -2. and -8 gets mapped to 4. What I want to try to avoid doing on a problem like this is connecting all these dots. Right now, this is a discontinuous graph. I don't know about any of the values between 3 and 6, so I can't just assume that I can connect these dots. 3, 6 should actually be right here. Made a little mistake. So I don't know about any of these values between 3 and 6. I can't just assume that I can connect these dots, because that would imply that 4 would also map to 5, and 5 would map to 5. I don't know that, so I don't want to connect these dots. I want to keep this discontinuous. To decide if a relation is a function based on its graph, I need to use what is called the vertical line test. The vertical line test works like this. I should be able to draw a vertical line through all of my input values and only hit one output. There are no vertical lines that hit this graph more than once. So this graph passes the vertical line test. Let's look at problem number 2. Start by finding the domain and the range. The domain is a set of numbers, 1, 2, and 3. And the range is also 1, 2, and 3. I don't need to list this 1 twice in my range. I just need to list it once. Notice that my domain and my range are just sets of numbers. They don't tell me how the numbers map to each other. 1 doesn't line up with 1. 1 actually lines up with 3. That's what this mapping does. Is this a function? Well, 1 has 1 output, 3 has 1 output, but 2 has 2 outputs. So this is not a function. In math, we want to work with functions. We want to work with relations where if we put in a number, we know exactly what the answer is going to be. In this relation, if I input 2, I don't know what my answer should be. Mathematicians don't like problems where we don't know what the answer is. It could be 2 or it could be 1. We like to say exactly what the answer is. If we input 1, the answer is exactly 3. If we input 3, the exact answer is exactly 1. We don't like the mystery. Let's look at the graph of this. 1 goes to 3. I input 1, output 3. I input 2, and I output 2. If I input 2, I can also output 1. And I can input 3 and output 1. Again, I want to avoid connecting these dots. I don't know what happens between 1 and 2. I don't have any idea what happens between the values between 1 and 2, so I don't want to connect. I want to keep this discontinuous. And we've already decided that this is not a function because 2 has 2 outputs. But what does the graph look like? Well, if we look, it passes the vertical line test here, and it passes the vertical line test here, but at the value where x equals 2, this graph does not pass the vertical line test. I can draw a vertical line that hits this graph twice, here and here. So this particular graph fails the vertical line test. So looking at the graph, I can also tell that this is not a function because it does not pass the vertical line test.